All right, let's discuss creating a frequency distribution table, as well as a relative frequency distribution table. So in this case, we have an instructor gives a quiz at 25 students, and the number of minutes taken to complete the quiz are recorded. So if you look through here, there should be 25 numbers, each one the minutes of a certain student taking a quiz. Now, as a quick check, it looks like, oh, right there, notice these are not in order. We have to be very careful because they're not in order. We have to have a nice way of accounting for which ones we need to count. So in this case, using the data set, create a frequency distribution table. The purpose of this is to recognize that if we change the class interval, we get a different set of numbers for the frequency and the relative frequency percent, as well as the class width. Often that's given in the problem, and you just need to recognize how they are binning the information, or what kind of bins they're creating for you to put the information into. That one wouldn't go there, that one would go there. But sometimes you get to create it, and different ways of creating a class interval give you different looks. So in this case, we want the class interval between 3 and 9. We want to go through and count 1, 2, between 3 and 9. I only see 2. So the frequency would be 2. Now 2 out of 25, let me multiply by 4. This is 8 out of 100. That's 8%. Of course, you can also do 2 divided by 25 times 100 to get the percentage. And some of these might be easier to do with the calculator. Okay, 10 to 16. So let me cross out with the color the ones we've accounted for. 10 to 16. So 1, 2, 2. We have another 2. We know that's 8%. 17 to 23. 1, 2, 3, 4, 5, 6, 7. 17 to 23. 8. 8 of them. So they're a little bit harder to find when they're out of order. 8. What is the relative frequency for that? 8 over 25 times 100, 32%. Now, because this column is percent already, we don't have to write the percent in the column. 24 to 30. 1, 2, 3, 4, 5, 6, 7. I get 7 of those. 7. 7 times 4 is 28. That would be 28%. 31 through 37. You can use different colors. You can just be careful that you don't double count or miscount. 31 through 37. I have 1, 2, 3, 4, 5. 5 times 4 is 20%. 38 through 44, there's only 1 left, and that's 4%. Next, the class width. You can do the class width a couple of ways. The two easiest ways are to look at 2 consecutive lower ends of the class interval, like 10 and 3, and subtract them. 10 minus 3 is 7. 24 minus 17 is 7. 38 minus 31 is 7, etc. Or you can do the same with the upper class limits. 30 minus 23 is 7. 37 minus 30 is 7. For example, that one. Be careful, though, that you don't try to do like 9 minus 3 is 6. 16 minus 10 is 6. You don't subtract numbers upper and lower parts of one interval, because that gives you the wrong number. By the way, it always gives you one less than the true class width. You could do 30 minus 24 is 6 and then plus 1 to get the 7. But that's not as safe because people forget the plus 1 or they don't understand why the plus 1. If you're counting on your fingers between 3 and 9, you'd put your thumb out for 3 and then 4, 5, 6, 7, 8, 9. And you'd realize you've actually counted 7 numbers. Or if you say out loud 3, 4, 5, 6, 7, 8, 9, you will have spoken out 7 numbers. So that's where the extra one comes from. Anyway, go ahead and pause the video while you fill out the right side. What you should get, 4, that's 16%, 12, that's 48%, and 9, that's 36%, and this class width is 12. All right, I hope this helps.